Welcome back to Sine and Cosine, the functions, part 2. In this video, we're going to start by looking at a table of values. We'll fill out the following table, knowing that root 2 over 2 is approximately 0.7. Now remember, in some assignments you may have completed previously, you can see how 0.7 can be a percentage of a right triangle. Once we've filled in the table, let's try to sketch each graph by connecting the points. When we substitute a value or an angle in for x, let's start with the angle 0. We know that the y value, when we have an angle of 0 on a unit circle, is 0. That's how high you've gone in the y direction. At pi over 4, we have gone a height of root 2 over 2. At pi over 2, we've gone a height of 1. At 3 pi over 4, we're again at a height of root 2 over 2. At pi, we are again at a height of 0. At 5 pi over 4, we are at a height of negative root 2 over 2. At 3 pi over 2, we are at a height of negative 1. At 7 pi over 4, we are at a height of negative root 2 over 2. And at 2 pi, we are at a height of 0 again. If we wanted to draw this on our graph given, we'll call this height here 1 and negative 1. And we need to break this up into segments. So we'll go ahead and say that here along the horizontal axis is 2 pi, halfway there is 1 pi, and let's break it up even further. Let's say that if we split pi in half, we're at pi over 2. If we split pi over 2 in half, we'll have pi over 4. So we'll just keep breaking these up. So far I have pi over 4, pi over 2, 3 pi over 4, pi, and then 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Reduce your fractions, because if you think about this, these could all be written as denominators of 4 and then reduced. Now at 0, for my angle, or my input x, I'm at a height of 0. At pi over 4, I'm at root 2 over 2. At pi over 2, I'm at 1. At 3 pi over 4, I'm at 0.7 again. At pi, I'm at 0. At 5 pi over 4, I'm at negative 0.7. 3 pi over 2, I'm at negative 1. 7 pi over 4, I'm at negative root 2 over 2 again, or negative 0.7. And at 2 pi, I'm at 0. If I connect these dots, I get something that looks like this. It's a nice, smooth, oscillating curve. It's called a periodic graph. So you would expect that the next period would look something similar, and I'm drawing that as a dotted line here. And it would just continue oscillating up and down as we go toward positive and negative infinity. So you can see how this would keep going in both directions. We're going to do the same thing for the table for cosine of x, but remember that for cosine, we're looking at the x, the change in x with respect to the angle. So we have to kind of break this down based on that information. Remember that if I break this unit circle up into quadrants, I'm going to have a value at 0 radians of 1 in the x direction. At pi over 4, I will be at root 2 over 2 in the x direction. At pi over 2, I will be at 0 in the x direction. At 3 pi over 4, again, I will be at negative root 2 over 2. At pi, I will be at negative 1. At 5 pi over 4, I will be at negative root 2 over 2. 3 pi over 2, again, I will be at 0. 7 pi over 4, I will be at positive root 2 over 2. And at 2 pi, I will be back at 1. So I'll just go ahead and fill this out in my table. Let's go ahead and sketch this graph, breaking my horizontal axis up into pieces. I'll label this as 2 pi. Half of that is pi. Half of that is pi over 2 and 3 pi over 2. Breaking it down even further, splitting all those into halves, I will have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Filling in the dots. At 0 radians, I'm at 1. At pi over 4, I'm at 0.7. Pi over 2, I'm at 0. 3 pi over 4, I'm at negative 0.7. At pi, I'm at negative 1. 5 pi over 4, I'm at negative 0.7 again. 3 pi over 2 gives me 0. 7 pi over 4 gives me positive 0.7. And 2 pi gives me 1. If I connect the dots, I get this interesting curve where it starts high, goes down to a minimum, and ends high again. So if I were to continue this pattern, you would see that it makes this kind of shape continuing in an oscillating manner. The reason I showed you how this corresponds with a unit circle is so that you could see how this is basically unwinding a unit circle representing x for cosine and y for sine. Here are the graphs of sine and cosine and how they should look. This is, of course, just a sketch, and depending on how you scale, sine and cosine can look very skinny and tall, or very shallow and horizontally stretched out. And it just depends on how you scale your window in a calculator or how you set up your pi and 2 pi along the horizontal axis and where you define your height to be.